Okay, hello everyone. Kristen here, and welcome to Polkadot broadcast. For this episode, it's an exclusive interview with a very special guest because he introduced the first AI vote in OpenGov, and it's really a big milestone. It's make the OpenGov more smart, faster, and more accessible. But here's a thing: most people in the community probably haven't had a chance to see it in action yet. And so, since only a small group is actively involving in OpenGov voting, so today we've invited the developer of Cybergov to walk us through it in detail. So let's welcome Kareem to join us today.
Thank you very much. Very happy to be here.
Okay. Um, to start with, uh, maybe you can give us some background information about, what gave you the idea to use AI for voting in the first place.
Sure, I'm very happy to do so. And hello, everyone watching. So, for Cybergov, the history goes a long time ago because I've been playing around with deep learning and machine learning for many, many years, starting with my time at Audi, where we were working on autonomous driving. So, we were doing some deep learning image detection in the cars. So, and that's where all my interest for machine learning and algorithms started, right? And I've been using language models since they came out. So many things that I tried BERT, I tried the basic first GPT-2 models. And then when ChatGPT came out, it was all, a fantastic thing that everybody, got attentive to. So with time, I learned to appreciate more and more local language models, so things that you can run at home. And I built a few machines to run models locally, and I have them do a few things. So I have some language models running in loops to do a few tasks and make sure that I do not spend time doing those tasks, but the machine solve problems for me. So at the same time, when I started noticing a lot of people using LLMs to submit and comment on OpenGov proposals. So in some cases, it was really obvious that this was, a proposal written by a language model. So
Mhm.
people are not just using them to write help, but sometimes also as a substitute for thinking, for thought. So I thought, why not use bots against bots, right? So I started playing around with this idea of Cybergov. The first version of Cybergov was called Naybot. So it's
Mhm.
available at naybot.xyz. It was a very simple rule-based voting mechanism. For example, if the proposal had no identity set, it would nay. If the proposal was a big proposal with a new person that nobody knows, it was a nay, etc. So classical rule-based mechanism. And then I
Mhm.
started adding language models to the mix, and it was pretty close to what people, were saying in the comments. So I thought, okay, why not scale it up? And it was exactly at the time where the Web3 Foundation started the new cohorts for the DV, introduced the DV Lite with no expectations to vote. So I tried, let's try this experiment. I was accepted, and I'm pretty happy about that. So that's roughly the whole history from the genesis to today.
Yeah, it's a great journey to launch this idea. And I think AI has been talking for years, but personally, for me, and it's really caught my attention is the ChatGPT because
Yes,
the interaction with ChatGPT we really changes the way we talk to AI. So I think it's uh that's why AI got popular. So. For the CyberGov, could you maybe give us a quick demo of how CyberGov actually cast a vote and
of course.
to show us that how easy it is that make the voting for people?
Absolutely. So first, on the point that you mentioned, I agree that when ChatGPT came out, it provided the excellent interface for people to interact with. So it was a
Mhm.
product that leverages the complicated algorithms that were
Yes.
developed to make it
Mhm.
accessible and solve a problem. And then since then, we all know it's history, right? Everybody loves that. So
Mhm.
for CyberGov, I prepared a few, like diagrams to walk
Mhm.
through how this thing votes. And I'll just share my screen in a little second if I find
Okay.
it. So here.
Yeah.
So can you please tell me if it's roughly visible and understandable? And at least can the text be read at this size?
Mm. Yeah, it is good. It is
Okay,
good.
excellent. So maybe just Cybergov, a very, very high level overview of how it works. At the
Mm-hmm.
beginning, we start by getting the data from Subsquare. And
Oh.
once we get the data from Subsquare, we store it somewhere to make it available to the language models. The data
Mm-hmm.
from Subsquare is called what we say raw data. So it needs to be improved and put in a shape that we
Mm-hmm.
can give then to the language models. So we need to remove some prompt injection attacks, some basic things where we want to make sure that the LLMs do not work on data that is not very useful. In some proposals, for example, they embed the images, which create
Mm-hmm.
very long strings that the LLMs cannot do anything without. So we remove those. We
Mm-hmm.
also then add some information to the data. For example, is the proposer a known person? Does the proposer have identity? What's the price of DOT or the price of Kusama in dollars? What's the size of the request? Those sort of things. With that, we create a little file that we then give to the three language models, so Balthazar, Melchior, and Caspar. They read this data as an input, and then they decide I, nay, or abstain. So every language model, every algorithm decides for itself without talking to the other algorithms. Here,
Mm-hmm.
Balthazar, for example, can be using the Gemini language model. Melchior can use, for example, Claude or Anthropic model, right? Caspar can use, for example, DeepSeek or the XAI, Grok model. Each of them use a different model, but the input data is the same.
Mm-hmm.
Once they have everything, they make their decision, and then a process picks up that decision and votes. As a high-level overview, we have the data collection and the voting that happen on my private machines, so private infrastructure, because just to save costs essentially, but also to make sure that we do not commit private keys for the voting to GitHub, because something can happen and they can leak. The voting, however, happens on public GitHub machines. This means that everybody can see and read what happens when the LLMs run. And they can see that I did not hide something in the prompts or interfere somehow with the vote. So it is completely automated from the point on where we collect the data. This is, maybe I'll share my other screen so you can see like example how this works.
Okay.
I'll go on the GitHub. So all the GitHub runs are public. You can see,
Mm-hmm.
for example, the vote on proposal 1714. You can open it, check the details, and run and view the logs and the details of every vote. So you can see what information was given to the language model, and you can see at the end the decision and the version manifest of that decision. What this means is a proof that this is the decision that the LLMs made, and the vote that will happen later uses this proof as an input. Complicated way to say that way we establish a link between my private infrastructure and the
Mm-hmm.
public infrastructure. So
Mm.
TLDR, to go back.
Oh. Oh, maybe he. Okay.
Wrong. Sorry, I clicked the wrong button. It looks very much like the share button in Google, so apologies.
Yeah, it's
So
okay.
share again and continue on the diagram, because
Mm-hmm.
then, when every language model votes,
Mm-hmm.
the V0 right now is an abstain heavy strategy. So we only vote if the bots say completely agree. So if we have 3 I, we vote I. If we have 3 nay, we vote nay. All the rest is abstain.
Mm-hmm.
Community members reached out and say that this is not very robust and it can be gamed, because people can just make long proposals and then the bots will abstain, or they can make a lot of external links and the bots will abstain. So that's why a v1 that is suggested to change the parameters is to add this change here. So if there are 2 nay and 1 abstain, we vote nay. If there are 2 aye and 1 abstain, we vote aye. That's a small tweak that we can add to the algorithm. So that's the TLDR of how the system works. It's a mix of private and public infrastructure for verifiable voting. It's not trustless because at the end we also trust GitHub to run the right machines. We trust, OpenRouter. It's the API that I use for the language models, and a whole lot other things baked in between to make sure that things are running. But people are using GitHub to release libraries, binaries, and all of that to run stuff. So maybe it's good enough for this use case. So yeah, that's the overview.
Okay, I think it's a great presentation to tell us that how it really works, what the procedure or process is it, and but for casting a vote, it's never too easy. Polkadot has been DV for twice, and to understand the proposal, first you have to understand the content first, and then there's some background information you have to know about Polkadot, or sometimes you have to know about Web3 or some broader information. So it's really complicated to cast a code, to cast a vote. So.
Yeah.
The procedure you just shared is a fundamental and how it works, but can really a AI could be so smart to handle all these complicated voting procedures?
Excellent question. And look, I fully agree with skeptics that might say that, look, the system isn't intelligent. And I agree. It is not an intelligent system that can think and act and all of that. It tries its best to read the proposal text and make an informed high-level decision, like cost, potential ROI, without taking past context into account. This is the V0. However, in parallel, what I've been doing, I've been collecting the past historical data from OpenGov and some contextual data to create embeddings of the history of Polkadot. What this means is providing the algorithms a way to look into the past and compare, is this proposal similar to something in the past? Is there more information that I can give the language models to make a decision? For example, is it a returning proposal? Is it a common good thing? Is it other stuff that might be worth funding or eyeing more than just the content of this single proposal? So Cybergov V0 is a very proposal per proposal focused, but the next iteration will have all the full history, the embeddings of the past, and more context engineered into it to make sure that the decision is less dumb, I would say. It won't be intelligent, but it can provide a first filter on, I would say, 80% of the proposal that can be clear cut, right? For the rest of the 20%, humans can spend their time and discuss and debate. So it is not a replacement for human decision making. It is more of an additional helping tool, like a summarizer or a note-taking app or something like that to help with the decision. And the cool thing with calculating the embeddings is you can do fun stuff like how similar is this proposal to other proposals, and you can provide these tools also to humans to view, what's the difference between proposal A, proposal B? Do we have a gap in our infrastructure? That sort of stuff. So I'll be releasing that, and I think the fun in the Cybergov experiment is all the products that I come up with on top that weren't directly related to Cybergov that could be good tools. For example, right now, when you search for something in Polkadot, it's difficult to find the latest up-to-date information, especially when it's about proposals. How many times did the person come back to OpenGov? How much did they ask cumulatively? How much different are their proposals? That sort of stuff. These analysis you'll be able to do with the tools that I'm building. And I'll show my screen just another time to show you that we'll be providing a small database that anyone can run, essentially. to make sure that they can query proposals locally. So this is essentially just a database that I have locally, a file that can give you all the proposal data, but also, all the information about the proposals themselves in a way that people can play with them in their Excel sheets and whatever. So this is like common good tooling that can help make governance easier or a bit simpler. So that's on the embedding side and how to make the language models less stupid. And so I think there's a lot to be made, but here's maybe the thesis and the bet. As time progresses, maybe the language models will become better. Maybe they become smarter, maybe they improve, as we see.
Mm-hmm.
We can replace the current APIs of the language models with the better ones without changing Cybergov at all. So Cybergov, in essence, is a data collection operation plus 10% language model layer on top with a vote and a comment.
Mm.
So that's the TLDR. Yeah.
Yeah, there's a data collection, there's the language model. So what's been the hardest part in keeping Cybergov not stupid?
Excellent. So honestly, the data quality has been the biggest challenge. So human generated data is very messy. It's non-standardized. People use, I don't know, different formatting for the proposal. People embed images. People add a bunch of links. And the problem with that, with adding links, is that the linked documents are difficult to collect and version and store. Because if you add a link to a Google Doc in a proposal, the person can always change what is in that proposal linked, right? Because the link in the proposal stays the same. The reference is the same. But the content within that reference can change. There's no trust in there. There's no verifiability. And somehow that is a big problem that introduced also challenges with Cybergov, because we do not have a Web3 way right now to submit proposal content without having to trust the proposer not to change their proposal after the fact. So that is one of the problem, the verifiability and making sure that the content of the proposal is fine. Because let's say I store a Google Doc and I save it. How can I prove later that I stored the correct version? The person can say, no, this is the correct version, and they edit it secretly, or I edit it secretly, right? You cannot prove that. So that's one of the big challenges, storing the data nicely. The other challenge that I have is how to run the system verifiably and trustlessly, right? The issue with running language models is you need strong GPUs, you need difficult infrastructure, costly infrastructure to run. This is why the trade-off right now is to run them on OpenRouter, on another API, and to have the runners run on GitHub. Because the second I casted the vote, the first vote for Cybergov, there was a comment from somebody saying that it's not verifiable and whatnot. So I was happy to have coded it in GitHub because I could just link to the public run and they can verify that the inputs match the process that led to the output. If I didn't do that, they tell you, oh, you're running shadow infrastructure and you're cheating. And there's a lot of accusations from ignorance, I would say, that can happen, where if I put all the infrastructure public, people might complain less. But the ultimate goal would be to run all of this trustlessly, but we can get there iteratively. So the next step would be to put the data collection, for example, on GitHub, or put the language models on a system where, I can run GPUs in a trustless way. There are some solutions for decentralized inference, but they're not in a place yet where I can completely use them nicely. So that's the second challenge. And the other thing is communicating the idea. That's been a difficult thing, explaining, how can bots work? And it's part of why I'm very happy to be here today to explain the system, to humanize it a little bit and just say it's a set of algorithms that are running and that's about it.
Yeah. And there are, really challenges in behind this. For the first challenge you mentioned, and there's more questions, like Cybergov only pulls in the proposal test from a subsquare, and doesn't look into external documents linked in the proposal. Do you see this as a risk, like potentially missing key information?
100%. So I always been open about that. This is absolutely a risk. But what I think is also more a risk is that we suffer from governance amnesia, right?
Mm-hmm.
When we're asked what was the proposal number 1200, whatever, a random proposal ID, can you prove to me that the document is the correct document that people used to vote? Not
Mm-hmm.
really. What we can prove, though, is that the subsquare calculates a content ID for whatever was provided and keeps the
Mm-hmm.
versions. So that's the closest thing that we could have to make sure that the proposal that people voted on, the content is correct. The
Mm-hmm.
linked documents, although convenient because you can add tables, you can add other stuff, you cannot trust those. Nothing against the people that do that. I mean, it's fair. It's a solution to make things work, but we need to solve that bigger problem: how to submit Web3 proposals in a Web3 way, and have them not being necessary to rely on trust. So there are a few things that we could build here to make that happen, and it would be exciting to see that work. There's a forum post also explaining how to prevent altering past proposals after they're submitted, and at least some work should go into that. And I think that's how we go to more of a truthful world and less trust in the proposals themselves. So yeah, key information in the docs is 100% missed, and unfortunately I have to say it's by design right now, because when I looked at the historical data, there's like 20 different solutions people use to submit linked proposals. There's Google Docs, people use Canva, people use HackMD, people use random different other things. For each, I need to develop an API to collect the data and store it. And still it won't be Web3. It will be best effort. So that's why I didn't do it. And, for a single person effort, on the side to my job at Parity, I thought, let's stay pragmatic. So that I agree with you. There's a huge risk of missing key information, but hopefully we'll come to a better optimum by developing a Web3 way to submit proposals. So sorry, that was a bit confusing, maybe on myself as well when I hear myself speaking. But yes, there is a risk.
Okay. Uh, okay. I think we lost the connection for a few seconds, but it's okay.
Okay, all right.
let's
So yeah.
let's continue. It's okay. Uh, mm, yeah. Even though there is not perfect now, but it's evolving. The most important is that we get it started. So for the real voting procedure, from my own experience, because Polkadot have been the DV, and we have three voters, and from my experience, sometimes voting is very bias. Different people hold different. Just it's not right and wrong. It's just they are
Yes.
taking the different perspective. Even there are even Polkadot cast a final voting, but there are discrepancy within the three voters. And so, how does Cybergov handle diverging views, and how does it decide on its final votes?
Correct. Okay. So first, on deciding the final vote. So I'll just share my screen quickly again, hopefully without leaving the, the call. So there we go. So right now, as explained a little bit earlier, this is the process, the mechanism. So, 2 I, 1 abstain lead to an abstain, 3 nay lead to an A. So these are the mechanical rules. But how does every single language model come to a vote? So what we do is we use a set of system prompts. It's behaviors, how we want the algorithms to behave, to tweak how they can decide and what they can decide. So right now, in the repository that is freely available, there are 3 personalities. The Balthazar system prompt, it's more a strategic analyst that will look at the proposal like a financial, decider. There's Caspar, which is more of a sustainability and risk analyst that has also a different behavior, sees the treasury as an investing vehicle. And there's also Melchior, which has a more of a growth-focused BD type of lens over things. By changing these behaviors of the language models, we can give them each a personality with on purpose diverging views. That way, when we cast the average of the votes or the majority of the votes, we get
Mhm.
to a consensus. Because if the growth algorithm, if the financial algorithm and the sustainability algorithm agree, there's a high likelihood that the proposal might have some merit and maybe we should eye it. If they
Mhm.
disagree, maybe we should abstain by the rules that I showed earlier. I'm accepting, submissions and PRs for improving these system prompts, changing them. And actually, a community member reached out and told me that this might be better. So I'll explore adding that for the system prompts and for the behaviors of the algorithms to make sure that maybe they change their behavior. And another thing that I'm adding for the community, because not everybody likes to use, GitHub, I'm adding a small form where they can say if the feedback was helpful and unhelpful. So every time they read the rationale or the conclusion of the algorithms, they can click and say, this was good, this was not good, and why. And then I can use that data to tune the behaviors of the algorithm for something that are helpful for OpenGov.
Hmm.
That's
It's a great way, but the language model itself, the are more and more tend to please the users. you know I already feel that ChatGPT is, when I ask the question to it, and when I say I'm not happy about it, and he will change it immediately. So I think the language model tend to be a bit too agreeable. So could that
yes.
create a bias or blind spots in governance decisions?
100%. So sometimes when I speak with the algorithms as well, sometimes I do not want them to agree with me. I tell them disagree. Tell me why this doesn't work. Like be contrarian. So
Uh-huh.
yes, I think the current system prompts of the Chat GPT and the things that you do not use in the API, so the chat interfaces, their system prompts are very tweaked to make the user happy, because a happy user keeps using the
Yes.
platform. So the target of these algorithms is to keep you using them.
Mhm.
However, in our case, we use the APIs where we have a bit more granular control over how we want the algorithms to behave. So this is why you can tell the algorithms do not agree with this, see it critically. And the
Mhm.
system prompt provided by the community member plays on that. So how you
Mhm.
engineer the context, how you engineer the system prompt can lead to LLMs that are less I don't know what the nice word for a live stream is, but like less agreeing with everything. Like
Mhm.
it's dangerous to have a machine that always agrees, because sometimes we can also be wrong. And if they agree with us being wrong, it just reinforces our bias and our, tunnel vision. So that
Mhm.
is a bit maybe more dangerous for people using ChatGPT to evaluate proposals themselves and
Mhm.
finding ways to disagree or to agree with their bias. So
Mhm.
instead of doing that hidden, everybody on their own computer and then commenting on a proposal, here we do it on the open. Here's the GitHub log. Here are the APIs. Here are the system prompts. You can replicate that. And that's I think the beauty of this system is because
Mhm.
governance is not done with LLMs in a hidden way, where people,
Mhm.
go on Subsquare, copy paste the proposal, go to ChatGPT, paste it, tell me why this is bad, boom, and wait, and then they copy paste the comment in Subsquare. So uh, those are the levers that we can do, and I hope to make this a collaborative effort. People saying that, hey, we should improve the system prompt this way, we should add this
Mhm.
as context, we should change this embedding, and then we can
Mhm.
find a, a tool that can give us a first pass. And to
Mhm.
make this also very simple for people, I'm running this also on Paseo. So if
Mhm.
people want to see before submitting their official proposal on Polkadot and Kusama, they can run it on Paseo and get a preview. And they can play with the algorithms and change a few things, request a revote, and get a feeling for what would an average or a college of language models think of this proposal. That
Mhm.
way, when other people come and copy paste it and get a different answer, we can compare those two. So yeah, I agree. LLMs are too agreeable and dangerously too agreeable right now.
Yeah. And we know it first, then we know how to handle it.
Correct. Yes.
And for the inputs and outputs, how do you make sure that the CyberGov, uh, the information, the inputs and outputs are verifiable and cannot be tampered with?
Excellent question, because this is where a lot of the thinking went into. And I also brought a nice graph. So let me share again. Okay, this is the right button. Let's go. So when we get the raw subsquare data, right? What we do is we do some processing to it, and then we create a content MD. This is what will be given to the language models, right? The language models can get this content MD plus the personalities that I showed you on GitHub, the system prompts, to decide on an outcome, like yes, I, no, nay, or abstain. Along these votes, what we create a manifest.json file. What this manifest is a hash of all the inputs and a hash of all the outputs, plus a hash of the code that was used to run this. And this is something that we provide when we cast the vote on chain. So people can verify, okay, what is the manifest file that was used for this? The manifest file links to the input and the outputs of the analysis. And then they can hash those independently and verify that these are in fact correct. So people can verify using these sets of files that I provide for every vote if the thing is correct. And I can share again the other screen where I can show you an example of this file. So here, for example, you can see for the system transparency and casting the vote, we add the manifest file. And when you open the manifest file, it looks like a JSON essentially. And it tells you what was used, the hash of the inputs, like the content MD and the raw subsquare data, and the hash of the outputs. And then people can compare that that is indeed the right thing that was used. Now, this was a test. This was run locally, so there's no GitHub repository. But if we go again to the actions, the official ones that run on Polkadot, you can see that the manifest files is also logged in the output of the GitHub text so that people can trust that I didn't change the file when I store it. So that is roughly how the vote is made verifiable through a series of hash surfing on top of Web 2 platforms. Like the files are stored on S3, not on IPFS, to make sure, that they don't disappear after a month or whatnot, because it's not pinned anymore or whatever. So that is a high-level overview how this works. So in the forum post, I explain a little bit more how the hashing functions, how it works, and in the code it's visible what these hashes are and how they function. Essentially, it's a way for me to show that this is correct. In the end, when we submit the vote, I will try to find an extrinsic for Cybergov. I submit a system remark with the hash of this manifest file. That way, we establish the link from the off-chain to the on-chain world by submitting the vote. No vote is cast without that hash. That way, that's how it's verified.
Yeah, it's great. I think some users cannot follow because there are a lot of informations, but don't worry, we will have the test version published in our WeChat channel, so you can keep an eye, and if you want to know more detail about this part. Okay.
Sorry if it's confusing and all of that. I'll send you the link for the technical breakdown, and then you can perhaps add. Yeah.
Cool. Okay, let's continue. The very important part is that people will make mistakes, and even though people cast a vote as a group or as a very important voter, sometimes people will make mistakes and then they will revoke their vote. So if the Cybergov makes a wrong vote, Is there a way for the community to trigger a revolt or appeal?
Absolutely. So, and has been baked in because the idea of having an algorithm decide on something human do is something that makes me think a lot. So that way, I need to provide people with a way to appeal and to say, no, I do not agree with this, or I do not understand how this works. So when we submit the vote, we provide a way for people, I'll share my screen again, to request a revote. Essentially, what a revote is we run the algorithm again. Like we make sure that people can what's called appeal. So I don't know, I'm sharing my screen. I don't know if that worked. Can you see? Yeah, perfect. So for requesting a revote, what you can do is you go to the Cybergov repository. So the issue is here, and you create a new issue. I created a template where people can ask for a revote. You add the information, what proposal, what network, what link, and a small explanation why you think it should be a revote. Maybe there was a mistake. Maybe it got the wrong data, or you noticed anything that is wrong. And once this is submitted, I'll take care of it and I'll recast a public revote again. A public revote is just running the inference again and casting the comment and the vote. I archive the old data, and that's about it. It's a very, very straightforward and simple process.
Okay, it's great to know. And time flies. And finally, looking ahead, what's next and what new features or verification methods are you planning to add in the future versions?
Yeah, so a lot of ideas. So the more I work on this, the more I have idea how to improve it. But the first one, the most requested one, is to add the history. So add the embeddings of the past proposal data. That way, if a person proposes something that looks like, for example, a storage solution, we can tell the algorithms, hey, there have been 3 storage solutions that are already funded. Maybe a fourth one doesn't make that much sense, or something like that, right? So adding the historical embeddings as part of the algorithms and open sourcing that. There's a bunch of also community requested features. For example, we want to have a small website to view the files, because looking at the JSON file is confusing for everyone. Nobody likes to do that. So maybe a small, pretty website that shows the outcome of the vote, why they voted, would be a good thing to browse through. Then improve the decision engine. So right now it's abstain heavy. Maybe we can tweak it to adding one more nay and one more I. And more documentation, how this thing votes, how people can run it themselves. People asked me, why doesn't this listen also to AAG so it can participate into AAG and add more information to the content? Not a bad idea. Why doesn't it speak in AAG and generate some audio that we can play, and this is the rationale of the vote? It could be a fun little gimmick, right? I think another thing is, when a revote happens, I want to have a logical link between the previous and the new vote. Right now, they're separate. So I want the language models to know, hey, this is a revote, person requested revote, here's the new context, that sort of thing. So a few little quality of life, but also essential improvements that we can add, hopefully a V1. Really, my target for the V0, if I get one delegation from other than the Web3 Foundation, I consider it a success and maybe worthwhile continuing. Otherwise, in January, maybe I'll stop the experiment, but leave the data collection part available for people that want to do the Cybergov side themselves. So they have the data and don't need to reinvent everything from scratch. Then, long-term stretch goal is to run this trustlessly, because it's using a lot of different services. S3, it's using GitHub, it's using other things. I need Web3 equivalents of these, or trustless equivalents, to run the whole system trustlessly. So what is a Web3 storage solution, right? What is a Web3 CDN? What is a Web3 workflow engine? Those sort of things we need to find, play around with, and integrate to fully make this work on chain. That would be a little dream of mine, right? But we're a bit far off, especially on the LLM and GPU side for now.
Yeah, I think it's really a great idea because Polkadot's OpenGov is really advanced in the DAO's management, and now the AI voting, it's I think it's the first one in this Web3 industry, and I think it's really meaningful, and I think the evolving of AI is very fast.
Yes,
So we. Mhm,
I agree, and it's exciting to be part of this and to bring
mhm,
Polkadot into this sort of parallel universe that is
mhm,
booming, the AI world, and find some bridges between people and showing good experiments. Because right
mhm.
now it's three language models, but how about we run 100 language models?
Yeah.
Will the quality improve? Will it not improve? Because at the end, they're like, slot machines. We're trying and seeing what comes out, and maybe it's good, maybe it's bad. But if we do it
Mhm,
many times, maybe the quality of the decision making will improve. Maybe the quality of the proposals themselves will improve in return.
mhm.
Who knows? So we'll track that.
Okay. You've already selected three language models. So these language models are kind of top ones, or why you
Correct.
choose?
So let me just look in the code to not say something wrong. But
Mhm,
right now, where are they? Right now, I think I'm using Claude for
mhm,
one of the decisions. I'm
mhm,
using ChatGPT for the
mhm,
other, and Grok AI. Yeah, here they are. Sorry. I use OpenAI GPT 4.0 for Balthazar. For
mhm,
Melchior, I'm using Gemini 2.5 Pro. And
mhm,
for Caspar, I'm using XAI Grok Code Fast. I
mhm,
think I will change this to GPT-5. I'll change the
mhm,
other to maybe the Claude 4 and see if the decision making improves.
mhm.
Yeah, so also open to PR suggestions how we can make those better and see if the quality of the decisions improves.
Yeah, I think it's really amazing for AIs that you are using the different language model. It's like you are hiring a top talented people working for you.
Yeah, well, absolutely. This is what I'm doing with my local models that I run locally. They
Mhm.
just run in a loop, and if it doesn't work, I just run it again, right? It's
Yeah.
not something that requires a lot of like mental involvement, I would say, or
Mhm.
like work. Really, it's a for loop. They try,
Mhm.
and at the end of the day, I come and pick the best solutions and try again. And
Yeah.
that's about it. Some people say, "Oh, it hallucinated APIs and whatnot." I just add to the prompt, "Please fix," and it
Mhm.
fixes it. And that's about it. So it's pretty cool utility to brute force your way to a solution. And once you
Mhm.
have that solution, you can ideate properly how to make it right. That's just an explorative tool to find
Yeah.
opportunities, maybe.
Yeah. Okay. Maybe to make sure that our audience can understand it in a tangible way, it's like for me, if I review a proposal, sometimes it takes me 3 hours to understand them. So, can you give us an idea of, how many proposals can Cybergov, you know, vote cast? How fast it is to to
So
to vote the cast? Yeah.
it's very fast. It's 2 minutes and it's done end to end. And it can, go through a lot of proposals. Right now, the past week, I've been tweaking a few of the things, community feedback, so I'll run it again. But I'm
Mm-hmm,
adding artificial delays between the time it votes to give people time to add their content, to give
mm-hmm,
people time to, have it make the decision deposit and all of that. So
mm-hmm,
it can go very quickly. And I think as a tool for people to submit proposals and try them out and improve them, it could be
mm-hmm,
very valuable, especially if we integrate it into a solution like a Web3 way to submit proposals, because then they get immediate feedback, or you're missing a budget, or you're missing other things, which are,
mm-hmm,
top three questions people ask when they get a proposal. Where is the cost going? Where is the ROI? Did you add that? Obvious things. And if
mm-hmm.
people add that at the beginning, humans will have an easier job afterwards to decide on the proposals.
Or if three different people are using the CyberGov, can they cast a different vote?
Um, so that perhaps the thing is the the language models are not deterministic. So if you run them again with the same content, they
Mm-hmm.
might come to a little bit of a different answer.
Mm-hmm.
There are ways to make sure that the language models give the same thing for the same input by
Mm-hmm.
setting the temperature, by setting other things. It's I'm not an expert enough to give the confidence on that, but it has to do with how language models work. They're probabilistic, token generation machines, rather
Mm-hmm.
than how Cybergov functions. So if we have an LLM that can give us always the same answer for a content, these people will make always the same vote. But if they differ even with a simple token output, it
Mm-hmm.
might diverge to a different outcome. Yes.
Mhm. And I think it's a question not only will happen in the OpenGov, it happens in every aspect that we use AI. It is, for example, if OpenGov develop very good and everyone want to use it. So I think every voters will use Cybergov to vote. So all the decisions, they are the AI's decision or human beings' decision.
Correct. Yes, and I think we're moving to a world where it's more bots against bots online, and humans have no chance. This is why projects like proof of personhood and all of that will be very relevant, because we will make sure that we are sure to discuss with the humans and not with the machine, right? We are
Mhm.
sure to interact with human generated content, at least like told that it was provided by a human. And that is one thing that I think we should be mindful of. A machine should always disclose that it is a machine. We should always say
Mhm.
that this was done with AI or this was not done with AI. And
Mhm.
right now we're in a state where it's a bit of a wild west. You do not know. You can say if people use an M dash, if people use a bullet points with at the beginning, bold text and bold text in the middle. You can infer that they might have used AI heavily to edit their content, but
Mhm.
it's difficult to completely eliminate AI. But
Mhm.
one thing that we can, at least in the DAO, agree on is disclose or say, hey, I used AI for this. The thoughts are mine, for example, or Cybergov. Here are all the outputs and inputs. This is done with AI clearly. The in the middle is dangerous.
Mm.
Yeah,
Okay. I think I think the solution is more than the issues we will encounter. So I think anyway it's good to take the boat, the AI's boat, and we are part of it. It's really cool. So I think we've touched a lot about CyberGov, and there's a tons of knowledge here today. And I think the audience need time to sink in. And I think for today, it's good for our conversation. And then later we will have the article, summarized and in the Chinese test in our and published in our WeChat channel. And if people are interested, you can follow our WeChat. And also we will have a highlight clips in published in our X account and also in our WeChat channel. So it's so happy to have Karim with us today, and thanks for sharing, and thanks for all the audience watching today. And we will keep closely to all the updates about CyberGov, and hope you can come back and share more information in the future. And
perfect. Would love to. Thank you very much for having me, and looking forward to any questions that come and improving the system for the community.
yeah, yeah, sure. If any users have questions, you can leave your comments in our WeChat, and to send direct emails to us or informations to us, or leave the comments in our WeChat, and we will collect them all and pass it to Kareem. Okay, let's all be part of it. Okay, very exciting.
Excellent.
Okay, thank you so much.
Thank you.
Bye.
Bye.
Okay.